All right, we're going to dive into a question that might sound a little weird at first, but it opens up this really cool space where engineering and biology collide. We're going to take a close look at the mechanics of the human hand by asking a pretty specific question.
I'm serious. Is your hand just a biological version of a diving board? It's a wild comparison, I know, but trust me, it gets right to the heart of what we're talking about today, a structure called a cantilever. So to figure this out, we've got to bridge a little gap here. See, engineers and biologists, they look at the world through different lenses and use different language. So before we can even start analyzing the hand, we need to get on the same page and understand what an engineer is talking about.
Okay, so first things first, let's nail down that engineering definition. This one concept is the key to this entire investigation.
You know, the definition itself is pretty straightforward. It really boils down to three key things. It's fixed at one end, it's totally free at the other, and, this is important, it's a single, rigid thing that bends when you put a load on it. That's the idea we're working with.
And once you get this concept, you start seeing cantilevers everywhere. Seriously. An airplane wing, a balcony hanging off a building, and of course, our good old diving board. They're all anchored on one side, hanging free on the other, and they're built to flex. Simple, passive structures.
All right, we've got our definition locked in. So let's see how it stacks up against the human hand. And you know what? At first glance, the argument that it is a cantilever is actually pretty compelling.
Just look at this comparison. On the surface, it maps out almost perfectly, doesn't it? You've got the wrist acting as that fixed end, the fingertips are the free end, and the whole thing bends to support a load when you, say, pick something up. It seems like a perfect fit.
And this quote from the biomechanical analysis really seems to seal the deal. The wrist is called a semi-rigid anchor. Well, that sounds an awful lot like the fixed base of a cantilever, right? This is probably the strongest point for the whole theory. But is it really the whole story?
Okay, but this is where we have to put on our detective hats and dig a little deeper. Because once you get past that surface level comparison and look at the actual anatomy, well, that's where the whole analogy starts to fall apart.
Let's start with a number, 27. That is how many individual bones are in your hand and wrist. A diving board is one solid piece of material. Your hand, on the other hand, is this incredibly complex machine made of 27 different parts. That alone tells you something's different here.
And this slide right here, this is where it all becomes crystal clear. A cantilever is one single rigid beam. Your hand is a whole collection of segments connected by joints. A cantilever's base doesn't move. Your wrist is incredibly mobile. But here's the biggest difference. A cantilever is passive. Your hand is active. It's constantly being adjusted by muscles and tendons. It's a dynamic tool, not a static plank.
So, after looking at both sides of the argument, what's the final verdict? We can finally answer our big question and, in the process, appreciate just how amazing the human hand truly is.
So there you have it. The final answer is a pretty clear no. The sheer complexity, all those joints, the active muscle control, it all means that the hand as a whole system is just fundamentally different from a simple cantilever. It was a neat analogy to get us started, but it's just not the truth.
But wait, here comes the really fascinating twist. While the whole hand isn't a cantilever, little parts of it can be. Think about it. When you press a button, you stabilize your hand, and for that brief moment, that one segment of your finger is acting exactly like a tiny cantilever beam. The principle is there. It's just happening on a much smaller, more precise scale.
So if the hand isn't a cantilever, what is it? Well, the proper term is this: a complex, multi-segment, multi-degree of freedom manipulator. I know, it's a mouthful, but all it really means is that our hands are built for incredible dexterity and precision, not just for holding stuff. A diving board can only bend one way. Your hand can play a piano or paint a masterpiece. That complexity is its superpower.
And all this kind of leaves us with one last, really cool question to think about. If our fingers can act as tiny cantilevers, what other simple machines from our engineering books are hiding inside our own bodies? You know, are our joints really just hinges? Is our jaw a type of lever? It just goes to show that sometimes the most sophisticated engineering isn't in a skyscraper. It's right here, in us. Thanks for joining me for this explainer.